So hi everyone, we're going to talk about section 1.2, which is on data classification. And the first classification of data is whether that data is qualitative or whether that data is quantitative. So what is qualitative? Qualitative data is generally an attribute. For instance, brown eyes, blue eyes, green eyes, an attribute. Or it's a label like first place, second place, third place. Or it's a non-numerical entry. Suppose we want to know about the percentage of people on the HUD campus who for easier label, a certain race or not. So if they're 70% Hispanic, the variable, the data, is qualitative. I want to know whether they're Hispanic or not, even though I use a number to say, well, 70% are this and 20% are that. So that's often what they call a non-numerical entry. And I'll let you think about that for a little bit. But I always like to think attributes or labels are qualitative. So what's a quantitative data? Well, quantitative data is a numerical measurement or count. All right? And so like your height or your weight or your age, those are numerical measurements and those are quantitative. So the first problems you're going to do in this case are you're going to try to decide if what they're asking you is qualitative or quantitative. And so you'll have to pick a word that describes it. Now, just so you know, some labels are kind of numerical in nature, like a phone number, all right, or a zip code. But those are really qualitative. Those aren't a measurement, which is the key word on quantitative. Okay. So, second slide about the levels of measurement. Where who is? No. Well, guess what? I just said all this stuff, but now I got to go back and say it because I forgot it. So, our levels of measurement are nominal, ordinal, interval, and ratio. And the nominal level right here is qualitative, and it's really only a name or a label. And those names or labels could be numbers as well. But for instance, your favorite type of music or your favorite TV show, it's qualitative, it's a name. It could also be like a zip code, all right, or a telephone number. Those are really just names of things or places. There's no real order to them that is meaningful at all. The ordinal level has order and rank to it. So for instance, the ordinal level, a good example of this would be like track meet placings, first, second, third, fourth, fifth, sixth place at a state meet. Those things have order, okay, and in some sense a rank. First place is a higher rank than third place, okay? You could even take like general, colonel, lieutenant colonel, major, captain. So the ranks in ROTC or military ranks, I'm not quite sure if I got those in order, but those have an order to them that is very specific, but you can't do any arithmetic with it. But that kind of measurement would be at the ordinal level. So suppose I have a variable that's at the interval level. Well, it's going to have order, but also, and this is the biggie, subtraction makes sense. So what do I mean by that? Well, if I have things at the interval level, suppose I have something like temperature. Temperature is a great example of an interval level. The temperature of 50 degrees is higher than 25 degrees, is higher than 0 degrees. Subtraction makes sense. 50 minus 30 degrees leaves 20 degrees warmer for 50 degrees, but the 0 is only positional. It doesn't really have a meaning. For instance, 0 degrees, it doesn't mean that there's no temperature. It just means it's on a scale. So 0 is really just a scale position. And 0 is just a number that's bigger than 10 below, but less than 10 above. So it's just positional, just keeping a place on a scale. So the ratio measurement has order, subtraction works, the 0 makes sense, and division or ratios also make sense. So a good example of the ratio level of measurement would be weight. For instance, 200 pounds is bigger than 150 is bigger than 100 pounds. Subtraction makes sense. If you take 200 minus 150 pounds, you can say that person is 50 pounds bigger than the other person. The 0 makes sense. If somebody or something weighs 0 pounds, it has no weight at all. Okay? So it's not just a position. All right? It actually has meaning. And then finally, division makes sense. If I put a 300-pound person and a 150-pound person, I can say the 300-pound person is twice as big. All right? 300 to 150 makes the ratio 2 to 1, or twice as big. So, as you do these problems today, you're going to have to decide which measurement, which level of measurement corresponds to what you're looking at. It's a challenging exercise. Make sure you look at the examples before you come to class.